And we're back. Hello, Algebra 2. So let's solve some systems of inequalities now. You were hoping the inequalities would go away. They didn't. They're not gonna. We're gonna see them again. Same with absolute values. Kind of hoping those would just go away. Maybe they were just a chapter 2 thing and we'll never see them again. Oh no, they're gonna be back too. So here's the what of solving systems of inequalities. We use systems of inequalities to solve problems where a range of solutions is possible. Sometimes the range of solutions is not only possible, but desirable. That's actually what we want to find. Not just what the probable solution is, but what are all possible solutions. And how we're going to do this is to graph the inequalities and find the region where the solution planes overlap. And we'll pick a test point from that region and make sure we did our work correctly. The only other way really to solve systems of inequalities is by using tables, and that works for small amounts of data, but when you start analyzing larger amounts of data, it gets very cumbersome. So we're going to focus on solving systems using graphing, because graphing works and is fairly simple in all situations. As far as the real-world applications, we're about to find out, and I think you can fill that part in on your own at the end of the video. If not, I highly recommend you read the chapter opener. No, I'm sorry, the section opener in your book. There's a little used car sales lot problem that I think is actually quite well done and illustrates the importance of systems of inequalities pretty well. Then theorems, again, not so much at this level. But why in the world do we do this? Well, this, again, is something I think you can answer when we're done. If not at the end of the video, probably by the end of class, our next class. All right, this is a short one. We're just doing one problem in this video. Here's the situation. An entrance exam has 2 sections, a verbal and a math. You can score a maximum of 1,600 points. For admission, the school in your choice requires math score of at least 600. Write a system of inequalities to model the scores. Yada, yada, yada. Okay, so, I mean, in what world could you get a 0 on verbal but still get 1,600 in math? I don't know, but this is the problem we have. Okay, so first things first, how are we going to write the system of inequalities? Well, we have to write some expressions first, don't we? Let's let M equal the math scores. And we'll let V equal verbal. That makes sense, right? Well, we know M plus V can't be more than 1,600, but it can be less than 1,600. So it can be 1,600 or less. And we know the math has to be at least 600. It can be 600, so 600 is a possible solution, which is why we have the little there, and why we have one there, because we can actually get a score of 1,600. You just can't get more than that. And here we need at least 600 in the math. So let's graph these bad boys. Now the good news is we don't have to worry about dotted lines, right? Because we have, in both cases, we have our little equal to bar. So we're going to have solid lines. But what else? I'm going to say, let's see. Call that 400, yeah? And we'll do the same thing down here. Easy enough to graph this first inequality, right? Actually, they're both easy to graph. We recognize the first inequality as being in standard form, right? We have an x term. It's really, yeah. And actually, let's rewrite this so that it matches my axes. Let's say v plus m. Because v is, I have verbal on the x-axis. So v plus m is less than or equal to 1600. And it doesn't matter actually how you set up your graph. You could just as easily have put math on the x-axis or the horizontal axis, but I put it on the vertical axis. And we know that if we substitute 0 for v, we get the m-intercept, which would be 1600 right there. And same is true if we substitute 0 for m. We get intercept, a v-intercept of 1600. And there's our line. We have to shade. In this case, we're going to shade underneath, right, because we're looking for points less than. And now let's do the same thing for m greater than or equal to 600. Let's find 600. There's 4. There's 6, right? Graph a solid line through that bad boy. In this case, however, we're going to shade above, right? Because we want our math score to be greater than. And all of these points that I'm shading right here satisfy inequality number 2. But only this now somewhat blackish region in here satisfies both. All of these points in that region satisfy both of the inequalities. And that's all there is to that. More in class. But in a nutshell, I mean, this is the method for solving systems of inequalities. And, well, we already know how to